project we did, and it's called Quick Strain for Beams. This program helps you find the maximum shear stress, maximum normal stress, maximum shear strain, and maximum normal strain in a solid uniform circular beam, which can be really helpful when in CE204, CE207 classes, also just in design in general. A really quick program and way to avoid having to do calculations for each maximum value. We
have decided to create 7 different function files for our project. The first one is called Quick Strain. It takes 4 input arguments, the first being shear stress, the second being normal stress, the third being Young's modulus, and the fourth being the shear modulus. From this, it returns 2 scalar values for normal and shear strain. Next, we have Quick Strain. This takes 3 input arguments that are scalars, the applied force, the torque, the radius, and the radius of the beam. This then will return 2 scalar values for normal and shear stress. Third function file is called shear. This takes 2 input arguments, the torque in Newton meters and the radius in meters. This will then return 1 scalar value for shear stress in newtons per meter squared. The next function file is then shear strain. This takes 2 input arguments that are scalars, the max shear stress in newtons per meter squared and the shear modulus in pascals. This will then return 1 scalar value for the max shear strain. The next function is the J value. J value takes 1 input argument as a scalar, which is the radius in meters, then returns the J value that is used to calculate torques. The units for the J value are in meters to the 4th. The next function file is called normal. This takes 2 input arguments that are scalars, given an axial force and the radius of a beam in meters, and returns 1 scalar value for the normal stress in newtons per meter squared. Finally, we have our last one called normal strain. Normal strain takes 2 input scalar arguments, the normal stress in Young's modulus in pascals, and returns 1 scalar value for the normal strain. Those are 7 function files that will be used in our project.
7 different function files, 1, 2, 3, 4, 5, 6, 7 that all run within our script. This is our full script here, and the program runs in the command window, so we will show you how it works. It starts off asking you what the applied axial force is. For this example, we'll do 25. And then the applied axial torque, also given in the problem, we'll do 10. And then the radius of the solid beam, which I will say is 0.5 meters. It tells us here that the maximum normal stress is 31.8310, and the maximum shear stress is 101.8592, and both values are in units of newtons per meter squared. And then it asks, do we want to proceed with the strain calculation? If you are just looking for the stresses, your problem only asks to find maximum stresses, then you would answer 0 for no. And it says, thank you for using Quick Strain for beams. So that is if you were just looking for the stresses. Now we can rerun the program and go through and find the strains as well. We'll clear command window and we'll run it same as before. Applied axial force 25 newtons, torque is 10 newton meters, and then the radius is 0.5. So we're given the same answers here, and if we want to proceed with the strain calculation, we'll answer 1 for yes. And then 2 other givens are Young's modulus and shear modulus. Those are properties of the specific material, so you would be given those in the problem too. For this example, we can do 5,000 pascals for Young's modulus and how about 3,000 for the shear modulus. And so our answers here are the maximum normal strain is 0.0064 and maximum shear strain is 0.034. These are both unitless values, so it's just like inches per inch or meter per meter. And then at the end it says, thank you for using Quick Strain for beams. Now we know that sometimes users may have errors with the program. So say that you're running the program, you're doing the stresses, and you're allowed to use negative values for any of the forces, because forces can be a negative. That just tells you the direction. But something you can't have is a negative radius. So say that someone tries to input -7 as the radius. We come back with error, invalid radius value. So the program will tell you if you're doing something wrong there. Another thing we troubleshooted, if we run it, say that we do it again, 25, 10, 0.5. Here's our values. Say that the user does not put 1 for yes or 0 for no, but puts like a totally different number. Say they do 35. We come back again with an error that says error, must report a 1 for yes or a 0 for no. So our program troubleshoots those things as well. Can be really helpful if you're in a mechanics of materials class, which we both are, which is why this program was something very important to us.